Hello, GeeCON. How is it going? End of the day, starting to get tired? A lot of learnings. Who is tired? Oh, yeah, makes sense. Who is not tired yet? Cool, no one. Okay, so for the next 50 minutes or so, we're going to talk about service mesh. Basically, what are they? Is it the new hype around this technology? Is it true? When it basically makes sense to start using service mesh, when it does not make sense, what limitations it offers, like it comes with, what advantages it offers. So we're going to try to answer all these questions throughout this presentation. But before that, please go to Slido. Make it a little bit easier. Scan the QR code. Go there if you have questions. Otherwise, slide.do and pick GeeCON 2022 and room 1. Going once, twice. Let's move. Before jumping into the technical discussion, actually, I want to start a little bit by talking about history, and specifically the history of the phone. So following the invention of the phone by Graham Bell, the first phones were basically oriented in peers, which limited the discussion only between the parties that were operating at both ends. But obviously that doesn't scale, right? So in order to scale, we invented what we call switchboards, and we needed for that to hire operators to manually route traffic between their to their final destinations. So in order to make a phone call, I will actually pick the phone, not to talk to the person I want to talk to, but actually to talk to an operator. And they will basically redirect me to the person that I want to talk to. And the further the call I want to make, the more operators I had to talk to. That scaled a bit, but didn't scale really well, because more phones means that we need more lines, and that means we need more switchboards, and we needed to hire more operators. And we needed to move away from the manual aspect of human interference to route the traffic to a more automatic, and even beyond that, to a digital way for like managing the communication and forwarding the communication. So this is what we did, basically. And if you're starting to get bored and worried, is it actually a technical talk? I bet it's yes. Because I think the way we are going, or the way we are moving forward, how we architect our applications, is actually similar. We started with monolith. It was really simple. We started to break the monolith down into smaller applications in order to scale. And the smaller our services became, the more problems we have to face and need solution to. The 5 seconds ads. Hello, everyone. Mohammed. I work at Spotify as a backend engineer. If you have any questions, even after that, I'm pretty active on Twitter. So yeah, if you want to chat anything about cloud native, Java, everything in between, please do not hesitate. Moving on. This is how the majority of our applications looked like in the 90s. All the components were tightly coupled in one single deployable or artifact. It was single flow communication between the server and the client. Really simple, but the problem is, if you are going to scale, this is actually gonna hit you hard. So in order to scale, we started to break the monolith into smaller services. And the rise of SOA, service-oriented applications, in 2000s, and we broke the monolith into smaller applications, and some means of interconnection was needed to coordinate the work, basically, of those services. And for that, we used MQs and DSBs. Who worked with one of these before? Enterprise service buses. Yeah, you had a lot of fun, guys, back in the time. And if you check the promise that enterprise service buses comes with back in the time, it was actually legit. And it looks like I tried to answer some of the current worries and some of the technology. It looks similar to some of the technologies that we are trying to build right now. But the problem with enterprise service buses, they were hard to operationalize. And the amount of coordination needed between the teams during deployment was really hard. However, No one picked enterprise service buses for agility or ease of use back in the time, but it seemed like the right tool because we had different constraints. And then in 2010, it was about making everything smaller. We moved toward DEM pipes and decentralized communications, like really fine-grained services with multiple binaries, probably written in different languages. And it does scale. You probably heard it in a blog post or in this conference, someone talking about it, like how we managed to scale really well using microservices. Some of the companies managed to deploy hundreds of microservices, and it does scale really well. However, the more services you have, the more points of failure you introduce, and the more problems you will face. Let's take actually one example. And let's take a look if the pointers will allow me. Oh, that's really small. So let's consider those two services. In the bottom right, your bottom right, service X and service Y. And service X calls service Y for, some business function. And then service Y becomes unhealthy. And service X, and each call that service X make to service Y takes more time because service X is incapable of handling error responses. So with each call, we increase the number of unavailable threads. The number of CPU, or the CPU consumption increased as well. And the number of available threads decreased, making service X unhealthy as well. And the same thing happened with other services, bringing the whole application to its knees. Now, you probably already know that, and it's called cascading failures. But the thing is, microservices and distributed systems at scale comes with its own challenges. And the more instances of anything you have, the more problems you will face. And this is how actually we look as developers and operations trying to solve the issue. Unfortunately, turning off the server doesn't work anymore. And distributed systems at scale follow actually Murphy's laws, which says anything that can go wrong will basically go wrong. The more instances of anything you have, the more the likelihood it will fail, probably at the same time. When we move it to those loosely coupled distributed services, services no longer start and stop in a predictable way. Like they can change their state. A lot of things can happen. But however, this is actually not true. This is true, but it's not like a new issue. It happened more than 20 years back. James Goldman and Peter Dutcher defined what we call the 8 fallacies of distributed systems. And let's actually go quickly go over them one by one. So we tend to think that the network is available, and it's actually not true. A lot of things can go wrong, like router updates, patches, DDoS attacks, outages. A lot of things can go wrong. That makes the network not reliable. We tend to think that the latency is 0, and we all know that there are 7 orders of magnitude difference between a call that is made over the network versus a call that is made in memory. We tend to think that the bandwidth is infinite, and this is generally not a problem nowadays. However, keep in mind that even if the bandwidth has improved and increased, the amount of data we send has also increased. We tend to think that the network is secure. And this is the fallacy that gets a lot of media attention, specifically. So unless you want to appear the next day in the news, you should make your application a little bit more secure and think about security while designing your architecture, especially if it's distributed. We tend to think that the topology doesn't change. And this is not true, especially nowadays with the rise of cloud and containers. And some elasticity is required in designing our topology. We aim to think that there is one administrator. This is obviously not true. We all know that. There is no one person that knows it all. Also, we tend to think that the transport cost is 0. And anyone who had the chance to view the cloud bill end of the month know that there is a cost associated with the transport. And finally, we tend to think that the network is homogeneous. We have no control over which path the request followed and which network it picked before arriving to our backend services. And there are other issues associated with those loosely coupled distributed services. Observing the interaction between services becomes a lot more harder because, yeah, we have a lot of them. And then how we can put instrumentation and monitoring tools becomes a lot more harder. Traffic management and doing things like A/B testing, canary deployment, blue-green deployments becomes a lot more complex now that you have those distributed, loosely coupled components. Also, securing the communication and the data flow in your microservice or distributed architecture, especially now that you have some of the application probably written in different languages. So how you can secure the data flowing inside your cluster. And finally, managing timeouts and communication failures, like that can lead to some sort of issues, like we mentioned, a cascading failure. So the thing is, when you think about how critical like the ability to control and secure service communication is to distributed systems, you start to think like we are kind of under-tooled. And same as happened with the phone, we need to move away from and provide better tooling to be better prepared for our distributed systems. And as I mentioned, those issues are not true. We had them previously, and we thought that we can solve them. And what we did first, we had a couple of attempts. And we had this message broker, this messaging-oriented middleware that we had to control the communication flowing in service-oriented application. And we said, let's actually put those infrastructure concerns, think like rate limiting, service discovery, and back pressure, all those stuff, into already a message broker that we have. This turned out to be a bottleneck, because it was already hard to, the message broker doing a lot of stuff. Adding those stuff was really complicated and turned out to be a bottleneck. And then, we were using Enterprise Service Bus, which was a good technology back in the time, and said, let's add those network features and infrastructure concerns to the Enterprise Service Bus we have. However, as I mentioned before, Service Bus was hard by its own. Adding those features makes it a lot more harder, and the amount of coordination needed between teams to do anything was basically a lot harder. And finally, with the rise of API first mindset and the risk evolution, we invented a new piece of software infrastructure, which is the API gateways. Now, API gateways provide a single point of management for your APIs, like throws API quotas and provide security. However, it does not solve the problem of east-west traffic, which is the traffic of your intra-cluster communication. And it becomes problematic because we started mixing business logic with infrastructure concerns, which, obviously is not a good idea. And with the rise of microservices, some of the companies that managed to succeed, what they did basically is client libraries. And it worked really well. What we did is basically we started to provide those client libraries and put infrastructure concerns there, things like load balancing, service discovery, client side, and circuit breaking, a lot of stuff. Put them into a small, tiny little bit client library, embedded with the code, package it with the code, and deploy it. It worked really well. But the problem is, we are mixing the business logic with infrastructure concern, that's one. And it's hard to operationalize, especially if you have multiple languages. The people that, especially Netflix, that managed to succeed had at least one language at most for the client libraries to succeed. So you are limiting your choices, basically. And similarly to what happened with the phone, we need to move away from, we need a more innovative solution to manage those infrastructure concerns. And what we think of, or ideally, would be to take those infrastructure concerns and put them down a layer, put them to where they belong, which is basically the infrastructure. Now, think about it. Isn't it awesome if you can, as developer, focus on the things that you can do the best, writing code, improving user experience, without having to worry of managing those client libraries without the hassle of maintaining them across the whole fleet. Unfortunately, this is not doable because, yeah, the infrastructure is fixed. We cannot change the network layers. And yeah, are we doomed? Not really. So some people managed to implement the same thing using the sidecar pattern. So the idea here is we're extracting those network features and infrastructure concerns out from the application, putting it in a small piece of software engineering, which is like a small proxy, and adding it so the traffic no longer go directly to its, so a service no longer call directly its downstream dependency, but the traffic goes first to this small piece of software that transparently adds the desired features. And this is actually how the service mesh was born. So the service mesh is not an invention of new technology, but rather like a shift from where the implementation is located. And obviously, it provides a lot of features that enable you to control and secure the communications that is running between your applications. So as I mentioned, with the service mesh, we took application or we took infrastructure concerns and network features out of the application, and we put it down a layer. So applications now, especially developers, no longer need to worry about managing those applications, like client libraries, like timeouts, communication failures, and stuff, and designing specific libraries for them. Those small piece is automatically like handle all the traffic, and we can decouple application features or our business logic from those infrastructure features. And as anything is declarative now, especially in the infrastructure world, you can think of service mesh as a programmable framework that enable you to observe, secure, and connect your microservices. That means that, or your distributed architecture, that means that you are declaring your attentions. And there is like a layer that, or a management layer that handles applying those attentions in your cluster. And the promise here is to make the communication between those services more, or yeah, through a cluster, more flexible, reliable, and secure, hopefully. And this is a helicopter view of how a typical deployment of service mesh would look like. Since I mentioned before, the traffic is so the service is no longer calling their downstream dependencies directly, and the traffic is routed first to the proxies. The deployment would look like as an array of connected proxies that add transparently the desired features. And there is a, okay, yeah, so that's the screen. And a typical service mesh architecture would contain at least 2 planes. And the first one is the data plane, and this is basically the proxies. And it's basically handle the traffic coming inside or outside your cluster. So whether the traffic is entering or leaving your cluster, which we call the ingress or egress gateways, the traffic needs to be first directed to the data plane for handling before leaving your cluster. And the second important layer is the control plane. It's a single point of administration of your cluster. It provides policies and controls for the proxies, and it also take a set of isolated proxies and turn them into what we call a service mesh. And this is important to keep in mind. Do not, what is it called? Do not, I lost the word, but be sure to not confuse service mesh or service mesh with a mesh of services. Mesh of services are basically all the services that, yeah, in your cluster, coordinating to make your application work. However, the service mesh is the management layer that adds the desired feature to your cluster. As Zach Butcher, which is one of the first and known faces in the SEO community and service mesh community in general, said, if it doesn't have a control plane, it ain't a service mesh. And I probably hear some of you saying, didn't we solve this before with containers and container orchestrators? Well, not really. Containers provide generic, non-language specific application lifetime management. Orchestration tools are basically generic, non-language specific platforms that handle a lot of things. Resources, efficiently scaling resources, the lifetime of your application, handling the load, and a lot of things. And the promise of service mesh here is basically to provide a response to some of the service level needs that are not provided by in orchestration tools, such as circuit breaking, back pressure, timeout, retries. All of these are provided by the service mesh. So they are kind of nicely work together and complete each other. And yeah, it's not only about microservices. Non-distributed monolith application will stay around for a long time. So service mesh will definitely help in their modernization, onboarding them to the mesh. There are a lot of things that service mesh can help with in a monolith application. However, keep in mind that the more services you have, the greater the benefit, as we will see in a minute in the demo. And this is a quick overview of the service mesh ecosystem. You probably heard of the big three, I like to call them, console, Linkerd, and SEO. And, but there are also a lot of other service mesh solutions that are pushing the community forward and providing nice features. Yeah, some of service mesh features. Let's go quickly over them one by one, like traffic management, things like A/B testing, canary deployment, blue-green deployment, routing requests based on some metadata. It could be a user header. You can inject context to decide if you want to request, where to forward the request, basically. Yeah, this is pretty cool. We're going to see it in the demo. Resiliency features, a lot of things, circuit breaking, timeout, retries. Those are all supported and came out of the box. Yeah, you definitely need to like configure it, but the solution and the infrastructure is there, and the solution is there for you to use it. Security features. Most service mesh provide policies, enable you to declare or define which services can talk to which service. This is important. Enable you more specification and extending it to control and like making your own policies over deciding which service can talk to which service. This is a great win, especially from a security point of view. And most service mesh provide certificate authority that generate certificates and enable to do MTLS, mutual TLS, which like making the intra-cluster communication encrypted. Finally, observability. This is my favorite feature of service mesh because it comes out of the box, especially black box monitoring. And yeah, traces in form of spans and annotations, metrics, gauges, histograms, diagrams, logs. Yeah, this is also supported in service mesh. And my favorite part, SEO. And going back to here, but why I picked SEO? Because based on Safe survey, it's kind of the widely most adopted, especially in production nowadays. So I thought it probably makes sense to do a demo with SEO. And there's an application deployed in the cloud, running Kubernetes, a microservice application. It's going to be a live demo. Grab your phone, scan the application, and go to my sock shop. Please, if you want. Otherwise, I don't want to bother your comfort. So if you go to the link, it's going to be a nice sock shop application, e-commerce application. A little bit warning, the last time I did the same demo, my cluster failed really hard. I hope it's not today, because I hope I resized it properly, but just for warning. Is it done? Okay, cool. What happened? Okay. Yeah, cool. Is the application still running? Yes, it is. Cool. Try to register, make a purchase, check out, hit all the applications. It's this is the application basically. Let me log in. Nope. Free ad? Nope. Thank you. And then, yeah, you can check the catalog, the available socks, amazing socks, right? And then add them, and then buy them, right? It's completely free. No. Okay, this is what I said. Yeah, awesome. The same issue. This is so weird. Yeah, it failed again. Yeah. Okay. 3, 4, hopefully. This makes sense. Okay, can you give it a minute? Probably a scale issue. Damn. But however, this is a great thing to, yeah, it's coming back. It's a great thing to demonstrate. Like, hit it again. Let's break it again. And then, so the application is a microservice application. A couple of services. Probably I can zoom in here if I can. No, yeah, no, doesn't work. So probably I can go here. A lot of application, front end, checkout, the cart, a lot of things. And then, yeah, you hit it really hard. That's cool. And then what I can do is I have another version of the application deployed, which is V2. That you can't see it actually because it's. I'm basically changing the. Sorry for the hustle. I'm basically changing the color to blue. So what I can do is forward all the traffic to the V2 application, right? So what I can do is no blue-green. I want to deploy the second one. So if I go here and make it V2 and V2, and then kubectl, please apply. Yeah, before that, apply -f. I want to deploy the application, so let's call it cleanup. Okay. So yeah, no, not deploy. Sorry. I want to call it traffic. Yeah, to traffic management cleanup. This one, right? So what I'm doing here is basically there are two important things in service mesh. There are the virtual service and the destination rule. So the destination rule is where you want to send the traffic, and the virtual service is what to do basically when the traffic hits in. So I hope now that if you refresh the page, you're going to see the red version. No? Not even in my dream? No? This is so weird. Yeah, this is so hard. Okay, what is the... Did I miss something? And changed, configured. Yeah, it should be... Yeah, okay, front end V2 probably. This is cool. Yeah, V2. Sorry for that. Front end V2, I hope. Configured. Hope now it works. No, why? This is so weird. Okay, let me bring it back. Okay. Did I save it? No, I didn't. This, yeah. Okay, it's back. But yeah, whatever. Stay with me. I'll don't hit it. Please keep it live. I will try to do some stuff. But yeah, as I mentioned, I have two versions: the front end and the back end. And what I'm going to do, so yeah, I have it here. That's cool. We can try, yeah, the blue-green deployment did work. We can try to canary one, right? So what I want you to do is 80% of the time, we're going to send the traffic to the blue version. 20% of the time, send it to the red version. So for that, I can called the canary, right? And yeah, the canary. Please. So now if you try to refresh, don't do it, I will do it, please. You will hit 20% of the time the red version, and the other of the time is the blue version. So this is good in a way that it enables you to gain confidence over the releases, especially if you are not so confident about your releases, or run experiments. Because, yeah, if you want enable a feature only for a set of users, you can use like canary deployment for that. What we can also do is route based on some metadata. So, for example, here what I'm doing is I want all Chrome users to have the V2 version, which is the red version. However, all other browsers to keep using the old version, the blue one. What I can do here is, yeah, deploy that. I have my configuration file. I call it route header, right? And then front end too. Yeah, that's good. So now what I'm going to see, or what I should see, is the red version on all my Chrome. Right? All Chrome users will see only the red version. However, if I am a Safari user, unhealthy upstream. Amazing. Why? Probably Safari is the cache thing. What was the URL? Okay. Yeah, blue version. That was a cache thing. Okay. If you grab your phone, hit the pick Safari, you will get to the blue one. If not, you will get the red one. Right? What I can do. So this is some of the traffic management features of Service Mesh that can be offered. Retry, resiliency features, circuit breaking, fault injection, load balancing, all of that provided out of the box using Service Mesh. What I want you to do, yeah, observability. Let's go to this is my favorite features in a lot of ways, because microservices are hard, distributed systems are really hard. So Service Mesh provide observability out of the box and provide a lot of tools, open source tools, and combine them. And they came out of the box. Let's start with Kayali. Hello. Oh, this is so fun. Okay, 3, 4, yeah. Kayali, don't let me down, please. No, it's not working. How about Jaeger? No, it's not working. Impossible. Amazing. What's going on? Okay, let me check my services. Did I broke something? No, it's running. Probably I messed up something. So if I go here, okay, so if I see here, yeah, I have my ECU cluster running here, and all of the services are running. Should be. So if I try to run them again, okay, so observability and expose dashboards, and yeah, is it that one? Yes, probably. No, not this one. I think it's, yeah, dashboards. Yeah, dashboard on a virtual services. Yeah, applying the same configuration that I had before, so it's unchanged and change it. Okay, how about the gateway? I think the gateway should be fine. How about now? Please? No? No? Yeah, shame. How about? Yeah, that was a failure again. Sorry for that, guys. Okay, but the application is still running, and my cluster is still running. That's so weird. Dashboard, gateway, yes. Yeah. Okay. Hello? No? Nothing? Grafana? No. So that's something. There is something weird in here. That's really weird. Anyway. Yeah, what I can demonstrate as well, it's yeah, security, the service is MTLS, but I'm not sure you can see that. Resiliency, we can What is the fault resiliency? Yes, we can actually try to introduce some delay. Where is the delay here? Traffic management, retry timeouts, no. Anyways, policy, the courts. I want the delay option. The delay file, yes, it's basically, so what I'm trying to do is introducing faults in my application. Since the traffic goes first to the sidecar proxy, you can do whatever you want with the traffic, right? So you can do some crazy things to simulate in case of failures, what's also known as chaos engineering. So what I'm doing here, and hopefully I can find it. So it's in the resiliency. It's in the resiliency, fault injection, and delays. So what I'm doing here is I want to introduce a 5 seconds delay for all calls to my catalog service. Now, if that will work obviously, because apparently I'm having a hard time. So it's configured. If I go to my application, if it's still up and running, so it's going to take more than 5 seconds to get an answer. Why? Because we introduced fault injection. This is a good thing if you want to try experimenting with, or start experimenting with chaos engineering, especially with SEO, or with service mesh, to enable you quickly to do that. And yeah, we can abort failures, like we can return 500s. So all the calls now will basically fail. We can do that. We're having fun, right? So fault injection, yeah, that's true. I want to abort. Please, yes, that's cool. So now, the catalog service, if I go here, hopefully, no, didn't work. Yeah, the catalog service is unhealthy, nothing. So even if your application is working, yeah, it's completely working, you can start experimenting and introducing faults and delays. This is a great way to learn about your application, especially when things go wrong, like now. And increase your confidence, especially resiliency confidence of your application. I hope service back to life. I don't know what's happening with the resiliency one. That's really weird. It shouldn't be the case. Service are back up and running. How about this one? No, cannot get Grafana. Anyways, that's so weird. Back to my slides. That was a complete failure. Now you get the answer to, do I need a service mesh? No, definitely, they broke during the demos. In a more serious note, do you need it? Well, if you think you do, think again. And if you really think you need it, then do your homework and find the right use case for it. A couple of use cases include modernizing your existing infrastructure. A lot of companies will have existing infrastructures. Rather than containers, those services and applications could be running anywhere, mainframe, their own VMs, bare metal, whatever. Service mesh will help eventually and hopefully in their modernization. How? It can provide facets to them to onboard them to the mesh. So that will enable them to not add or rewrite the whole application or start adopting whatever pattern or architecture like microservices or go into the cloud eventually. Another use case when it does make sense to use service mesh is service prowl. When you have a lot of services and you don't know how well those services are doing. Service mesh, especially the observability features that wasn't working, if it did, you would see it. But it will help to gain an understanding of how well your application is doing, and then resize your application or resize your cluster and define your capacity need, basically. Another great use case is monolith to service migration. If you want to pull out some functionality out from a monolith, then service mesh can help with that. You can start by testing your application, like providing access to a specific set of users, and then once the application, once you are sure the services or the functionalities, you move it or you pull it out match, you can reroute the traffic to the new service. Another interesting use case is the release bottlenecks. If you are having trouble with your releases, Service Mesh can help you with gaining confidence over your releases. You can start by allowing access to new features to a set of specific users, as we saw, like using specific metadata, and then gradually rolling out a small percentage, 1%, and then gradually rolling out until you are really confident about your releases. Interesting use case, debugging microservices. I think I already mentioned that. Microservices are really hard to debug. And yeah, Service Mesh provide an array set of features, time series databases and tracing in Jaeger and stuff. It's pretty cool. Finally, chaos engineering. If you want to gain confidence over your application, especially the release or the resiliency confidence, you can start doing crazy stuff with it. Like you can start introducing delays that we saw, returning 400s, 500s, and you can go big afterward if you want. Make sure to not get fired while playing with it. An interesting graph from the Nginx folks, which says that as the complexity of your distributed architecture grows, Service Mesh becomes a more realistic approach to implement those features, especially infrastructure features and network features, service by service. And they also mentioned that as the technology matures, they believe that the tipping point will go down, making the adoption of Service Mesh a lot more affordable. Another interesting graphs from Kinvolk folks this time, where they did a benchmarking for running the same application with Linkerd, environmental, and with SEO. And they found that Service Mesh is not free. It comes with a cost. And you can see here the latency cost it introduced, the memory usage, and also the CPU consumption. So yeah, it adds a little bit of overhead. So be aware of that. And the hope here is, as the technology gain a lot of maturity, those numbers will eventually go down. But then you need to do your homework and see where the Service Mesh would fit. Yeah, this is the CPU utilization, sorry for that. And think about other costs. One of the other costs you need to think about is the architectural lock-in. So the client library is widely used by a lot of folks in the industry. And what we're trying to do with Service Mesh is to take the client library features, or the client library model pattern, if you will, and then put those concerns out of the application and put it down to the infrastructure. Now, this is good if you get it right. However, if it didn't work, like the one I had a couple of moments ago, rolling back will be really hard. So imagine the same issue you had at a larger scale. So yeah, you need basically to do your homework and then think about the cost as well. And also think about the environment drift. This is a new technology. Yeah, it's a new challenge. And also think about the learning curve. It's a new technology. So your colleagues, your employees needs to get familiar with it, know the problems it offers, hear a lot about it before they can be familiar and master the new technology, basically. Yeah, final slide. A couple of takeaways. As we mentioned, Service Mesh, the promise here is to allow you to observe, secure, and connect, and like offer some of the features that are nice to have or necessary to have for highly distributed applications with less hassle. It's new technology, but however, implementing patterns. It comes with a cost. If you want to implement it, think about it more than one time. It's cool, but it comes with definitely a cost. So yeah, you need to do your homework, and it brings value for both monolith and microservice architecture. A couple of useful links. The demo here, the demo that broke hilariously, it's available on GitHub. I don't have a link, so if I open this one, it's a. Oh, I was afraid that didn't work as well. It's a self-work-through tutorial. It's basically have like all the functionalities I mentioned here that you can play with. You can deploy it in your own cluster or in the cloud, if you will. Yeah, it's basically you can go there, have fun, and hopefully it will work and not fail as the one did. And a couple of blogs and books that helped me to build the talk. And I think that's it for me. Yeah, go into the questions. Cool. Latest question. Does it make sense to use service mesh in an event-driven system? Yes, it does. I mean, it depends on the need. It will provide value. Like you would need those features, like to provide the events. You will need retries mechanisms. Probably it will help. And yeah, it will provide value, but it depends on the need you need it for. If you can be more specific, but I think it will help. There are a lot of things. The security of the events you said, encrypting them, both from edge to edge. That can be a great win as well. So monitoring, probably you have that, but then it can offer other types of monitoring. So there are a lot of features. You can pick the one you need without worrying about the others. Where I did deploy my app, Google Cloud. What is the difference between service mesh and API gateway, reverse proxy, and which one to use in what use case? So I think I mentioned this in the slides. So API gateways and reverse proxy are like before the request enter your cluster. So think this is the outside world, this is the internet, and then the API gateway or reverse proxy, whatever you want, and then your application here. So the API gateway only handles the traffic that's coming into your cluster, and that's it. However, the service mesh, the promise here, is that it manages the intra-cluster communication, which is the east-west traffic, the traffic running inside your inside your cluster. I hope I answered the question. Otherwise, just let me know. From Alex, have you considered to add caching somewhere in the traffic management feature? Caching, in which point, Alex? Alex here? Yes. Yeah. Yeah.
So you can put the cache into the traffic management layer so that the request will not hit the downstream service at all, but hit the service cache.
Yeah.
The response will be stored from there.
Yeah. Yeah. So the comment was, how about adding a cache, especially in highly distributed systems, right?
So this way you don't have to build the cache inside the service itself, but then you can kind of add the caching layer, whatever service you want, under certain conditions. So let's say the service responds with a special header.
Uh-huh.
This data is cacheable for 1 day.
Yeah.
Don't ask me again about that.
Yeah, you mean redirecting the cache from the proxy?
Yes, correct.
Yeah, you can do that. I mean, it's declarative, it's configurable. You can do whatever you want with it. Like you can deploy. It's gonna be tricky, but it's doable. Because because the proxies, you're gonna need another proxy in front of in front of your whole application without cache and the cache system. You know what I mean? Because what I mentioned here is the proxy is very lightweight and it lives next right to your application. So you need a kind of another proxy there that do the management layer and then send the traffic to whatever that one needed. Does it answer your question?
Yeah, partially. But I mean, we know that in the old days, when you have a proxy, for example, on the local host for
Yeah.
HTTP traffic,
Yeah.
then something could sort from that proxy.
Yeah.
It doesn't apply that to the service entirely. Say that the catalog service can respond once per 100 requests.
Yeah.
Because the data changes once per day, let's say.
Yeah.
I mean the cache is not the external service, which probably could be, but it's a part of the service mesh itself.
The caching is part of the service mesh?
Yeah.
Not really. Because the promise of service mesh is to stay away as oh, that's too much. Is to stay as away as possible from your business logic. That's a business logic concern, right? I mean, yeah, how you're gonna handle the caching is depends on your business need. Probably you don't need it. Probably need the data to be refreshed. It's flexible. You can define like your architecture however you want, but then yeah, it's doable as I mentioned, but then it depends heavily on your need. Probably we can take that discussion right after, right? Taking other questions. Do you think in the future orchestration like Kubernetes will have service mesh features out of the box? I honestly don't think so. It breaks the single responsibility principle. Kubernetes have a set of features that it excels at. So adding those functionalities will be an overkill, basically. So probably I am wrong, but I don't think it will be added. So yeah, service mesh basically tries to add those missing features. Does observability tracing work out of the box in SEO? Yes. Do I still need? Oh, yes, it worked. Did someone view the question? Do I still need? No, it works out of the box since there is the lightweight proxy there. It intercepts each comment and it transparently adds the span request needed for your tracing. So if the demo worked, we would have seen Jaeger and the span related with each one. Never mind. Yes, it added transparently, it comes out of the box. Graphs, SEO comes with Grafana, Prometheus, Kayali, which is an SEO dashboard, and Jaeger out of the box. You don't need to do anything, especially black box monitoring. You need to add your business metrics there. Last question, what is the limit of service mesh possibilities? Can I do stuff like exponential backup handling, and how much states can a sidecar handle? You can do exponential backup there, yeah, like the retries feature. It's in the demo. I didn't mention it, or I didn't do it, but yeah, there are the retries mechanism and exponential backup there. And how much state can a sidecar handle? What do you mean by state? I mean, because there is a problem that I am really aware of, which is the more big is your cluster, the more resources the sidecar need, because it needs to keep the state of each and every node in the cluster, especially the IP table configurations and where to find which cluster. So yes, it keeps state. So we need to define state here, if you will. And yeah, it keeps state and it takes some resources when it, especially in big clusters. As I mentioned in the slides, the graphs from Kinvolk, it's consume resources, both in memory and CPU. Big part of this memory is to keep the state. But please feel free to come by if I didn't answer your question. That was the last question, right? Thank you. And sorry for the demo.